Hi everyone, for this lesson we'll take a look at inductive reasoning, which is a thought process by way of observing patterns. That's why I have the I here, and we use that to discover relationships based on numbers or geometric figures. So the whole idea of inductive reasoning is to look for a pattern. So let's say we have this sequence of numbers here. We started off with 5 and then we went up to 10, 20, 40 and so on. So from here we can see that to go from 5 to 10 we had to multiply the 5 by 2, so times 2. And that's consistent for the next term here. So we started with 10 to get to 20. Again, we multiplied that by 2. And same thing with the 40. We multiplied the 20 by 2 to get the 40. So once you recognize that there is a pattern in this sequence, then you're ready to make a conjecture. And basically that's just the conclusion you make based on the inductive reasoning. With that said, you can use it to find the next term of this sequence. So the fifth term here would be just 80, because you take the 40 times it by 2, and then you can use that to find the next term and so on. Now if you need help coming up with the conjecture or to recognize a particular pattern, you can make a table, or if you want you can plot points on a graph and see if you can recognize if there's a pattern with the graph. So for example, let's say you have this graph here. The x-axis is the number of weeks and the y-axis is the dollar amount that you spend. So let's say the first week of the summer you spend roughly $10, and the second week roughly 20 and so on. So you realize that through inductive reasoning that there's a particular pattern here. So by examining this graph, you might have realized that as the number of weeks increase, so does the dollar amount that you spend. So if you were to make a conjecture or a prediction for the 6th week, you would say maybe it's roughly over here. Okay, because that will follow this linear pattern. Right, so on the 6th week you could have spent roughly $60. Okay, so if you were to carry on with your prediction, the next week will be somewhere over here, and so on. Now, if you can provide one example that will prove that the conjecture is false, then that is called a counterexample. In other words, the counterexample proves that the conjecture is incorrect. Okay, so that's why we have this big red X over the conjecture. So let's take a look at this idea where you connect 3 points and it will always form a triangle. So here's an example. You have these 3 points. If I were to connect them, right, the 3 points will make a triangle. So let's think of a counterexample. So what if you have 3 points that are collinear, just like the ones down here, right? And if we were to connect them, they don't form a triangle. So this would be a counterexample. Okay, so this would be a counterexample. So this example is a counterexample because it shows that the conjecture is false, right? So the original conjecture was if we were to have if we were to connect 3 points, it will always form a triangle. So this shows that this is false, therefore this is the counterexample. And we've reached the end, and we're done and we're happy.